Hello, this was our PRML project. In the project, our main objective was to examine the variable that influence the likelihood of experiencing a stroke and develop a predictive system for identifying stroke traces and the primary factors contributing to a stroke. Now let us explore the dataset. Following are the characteristics that were observed while performing EDA on the dataset. The dataset was highly imbalanced, which can have a negative impact on training machine learning models. This needs to be addressed through techniques like oversampling the minority class. The dataset only had null values in the BMI column. These values were replaced by the median of the column as the distribution observed was slightly skewed. As majority of the features were categorical, therefore encoding techniques were used. We used label encoding and one-hot encoding to prepare the data for machine learning algorithms. Both univariate as well as multivariate analysis were performed in order to gain more insights into the dataset. Following are the machine learning models that were used for stroke prediction. We made use of K Nearest Neighbour, random forest, decision tree, support vector machine, naive Bayes classifier, as well as multi-layer perceptron. We also made use of grid search CV for hyperparameter tuning in order to get best possible combination of parameters. This will increase our performance while training and testing on this dataset. As we know that we were asked to include unique ideas, so two unique ideas which we included were feature selection and SMOTE technique. Feature selection was performed to identify top 10 features that contribute the most to predicting stroke, whereas SMOTE technique was used as we know that our data set was highly imbalanced. So with the help of this technique, we were able to get equal number of labels while training the model. Both these techniques have highly improved our prediction. So here is the pictorial representation of results. We also plotted ROC curve. ROC curve was plotted to visualize the trade-off between the true positive rate and the false positive rate, allowing for a deeper understanding of the model's performance. As we can see from the graphs, random forest was our best performer. As you can see from the ROC curve, it was having highest area under the curve, which was 0.84. As we know, random forest was our best performer. So further analysis was done to get more insights. As we can see from the learning curve of the random forest model. Here both the lines shows that as the training set sizes increases from 0 to 5000, the cross validation score improves, indicating that the model is learning and generalizing better with more data. Conversely, the training score decreases slightly, which might indicate a reduced level of overfitting as the model has more data to learn from. Here we have listed out the stats of our best performer, random forest. Here are some insights which we found while performing EDA. The analysis revealed that older patients, particularly those over 40 years of age, are more likely to experience a stroke, with a small number of patients under 40 also affected. The data showed that males tend to have strokes at an older age, while females are more prone to strokes starting from their 30s. Patients working in the private sector had the highest incidence of strokes, followed by self-employed and government workers. The underweight patients were the least likely to have strokes, while the healthy weight class had a higher incidence compared to overweight and obese class. Here I have listed out the summary of our project. The future application that can be used to develop a practical system for early detection of stroke and prevention. This can help healthcare professionals identifying high risk individuals and implement targeted interventions to mitigate the impact of stroke. We also developed a demo code for practical purpose of our project. So here is our demo code. So this demo code was developed using our best performer random forest. Same parameters were used which we found with the help of Grid Search CV. Here are the input which we took from the user, and based upon input, our model predicted that the person is not prone to a stroke. So this was our project. Thank you.